Hello, my name is Samantha Grubb, and I'm here to talk to you about a project conducted by a large team of undergraduates and PhD students in Jim Magnuson's lab at the University of Connecticut. Our aim is to understand what makes one spoken word more difficult to process than another. By determining what factors predict processing time, we can provide new or more precise constraints for theories and models. In our study, we are considering some standard lexical dimensions. We start with frequency of occurrence. We then consider three phonological factors. The first two are conventional, so-called DAS, or DAS neighbors, and cohorts. DAS neighbors differ by no more than a single phonemic deletion, addition, or substitution, hence the DAS rule. The neighborhood activation model proposes that words with high global similarity, no more than one mismatch anywhere in the word, will compete strongly. Cohorts here overlap in the first two phonemes, a typical definition under the cohort model. On the cohort model, words are eliminated from consideration as soon as they mismatch, so only words overlapping at onset are expected to compete. Strong competition is expected if two words overlap at onset, no matter how much they mismatch later. We also coined a new category. Nohorts are words that are both neighbors and cohorts. We put them in a separate category to avoid overlap in the sets of neighbors and cohorts. Finally, we considered three other factors that are less often considered in studies of spoken word recognition: duration in milliseconds, task, lexical or semantic decision, and concreteness. I will briefly describe our design. We selected 508 monosyllabic and 508 bisyllabic nouns pseudo-randomly from a dictionary. Each word was produced by 4 talkers, 2 natural talkers, 1 female, 1 male, and 2 high-quality synthetic talkers, 1 female, 1 male. We collected 30 responses per item in lexical decision, press yes if what you hear is a word or no otherwise, and a simple semantic decision, press yes if you can touch the named item or no otherwise, using the online data collection tools Prolific and Gorilla. First, let's look at how consistent reaction times are for each item across talkers. F2 and M2 were the natural talkers, and Samantha and Tom were the synthetic talkers. Correlations were surprisingly low. This suggests that studies of spoken word recognition should strive to use multiple talkers to establish generalization. To examine our predictors, we considered reaction times from our lexical decision and semantic decision tasks with RT anchored to word onset or word offset. We conducted separate mixed effects regressions with RT as the dependent variable for each combination of task and RT anchor. We included random slopes and intercepts for subjects and items. Here, we plot the regression estimates in milliseconds based on analyses with standardized predictors. Thus, for a given predictor, a change of 1 standard deviation unit is associated with the plotted change in reaction time in milliseconds. We replicate standard frequency effects, with higher frequency associated with shorter RTs. We can see that duration has a huge effect when we onset anchor RTs. When we measure from onset, RT will be longer for longer words. It takes longer to get to the end of a word. When we anchor from offset, there is an advantage for longer words, presumably because more time has gone by since word onset and more phonemes have been heard, leading to stronger activation. Intriguingly, we get consistent, moderate effects of concreteness across tasks and RT anchors. Turning to our phonological factors, the results are somewhat surprising. Cohorts that are not also neighbors have negligible impact in lexical decision and very small impact in semantic decision. Neighbors that are not also cohorts have strong, consistent impact, and nohorts, items that meet the criteria for both neighbors and cohorts, show consistent impact, though with a trend for weaker impact than neighbors. The weak cohort effects are surprising, since cohorts have a larger impact on the time course of spoken word recognition, as estimated in visual world eye tracking. To conclude, we found high consistency across tasks, but concerningly low consistency across talkers. Duration needs to be considered carefully, as does the decision to anchor RTs at word onset versus offset. Frequency effects were robust, as expected. Concreteness effects were also robust and surprisingly consistent across tasks. We were surprised to see neighbors having so much more impact than cohorts. The phonological competition and concreteness results in particular may challenge current theories and models of spoken word recognition. Thank you, and I look forward to questions.